Hello, everyone. I'm Brianna Frank. I am the Director of Product here at IBM Cloud, and I am so excited to talk about IBM Cloud Satellite today with all of you. I know we have a few folks in the chat that can help answer questions, and I'll obviously answer questions at the end, so feel free to interact and give us some chat questions as they come up. All right. So, today we're going to talk about IBM Cloud Satellite. And again, feel free to connect with me on Twitter or LinkedIn if you have questions or you want to talk further. Would love to get, feedback, or if anyone would like to join our beta, would love to connect. So let's talk a little bit about where Satellite really originated. Where's this idea originated, where the product really was born. And that was with a real life client in the financial services industry. And this is such a great example because, the financial services industry, you kind of think about it, it's all about security and money. And it is, it's all about those things, but it's really about technology. And, many of us are users of financial technology, right? And so we're paying bills online, we're consuming information about our finances online, we're getting advice on what to invest in through technology. And those applications have to iterate very quickly because we as users are very demanding. And so financial institutions are constantly trying to find ways to make financial services easier to consume. And that often involves AI algorithms and new ways of making it easier for us to consume financial information. And, but that is kind of balanced with this pain point around the highly regulated nature of the financial industry. And so, there's all kinds of compliance constraints, there's, regulation, there are all kinds of reasons why moving fast is very difficult in this industry. And so we had a client come to us and say, what we really need is a cloud native consumption model, but in our on-prem data center. And is that something you guys, could help us with? And so we said, yeah, I think it is. And that was really the first, major use case that we solved for with Satellite. And so, we're just going to use an example of, we're going to call this Linden Go, a multinational bank for home mortgages. And the demand for new features, that agility, that speed of public cloud is really driving the Linden Go in the way that they're building and iterating on their applications. But the regulation policies of latency keeps their backend systems on-prem. So what IBM Cloud Satellite could do is standardize on on-demand services for Kubernetes, data, security, and AI, and distribute them across an on-prem, edge, and public cloud. So this means consistent tooling, financial service controls, and observability across environments, and cloud native tools that are available locally. And this allows someone like Linden Go to build new application in weeks instead of months. And they can update their application hundreds of times a day if they so choose. And so this was one of the very first use cases that we tackled with Satellite. And I think what's really interesting too is that, a lot of the financial compliance and controls that are built in with IBM Cloud, we can start to extend those to Satellite, as we move into 2021 to make it even more secure and more compliant moving forward. So let's talk about some of the challenges of hybrid cloud. So we gave a financial example, and I'll give a few other examples as I go along today. But one of the more common challenges we hear is around latency. So data processing must happen close to the data, alleviating latency, especially when using predictive AI and analytics. And so we hear that challenge quite a bit with many of our clients. Data residency. So we talked a little bit about that, in the beginning. Data must remain in country due to local regulations, compliance, and penalties can cost hundreds of millions or hundreds of pounds, depending on where you are. And lack of agility. So all of our clients across every industry, they're looking to move faster. And applications sprawl across many locations, and on-prem data centers, private clouds, public and edge, decrease development velocity. And finally, lack of visibility. Almost, every client we have is using 5 to 8 different clouds, and they need visibility of their digital platform and apps for each of those sites. And a lot of times they're having to, juggle between lots of different monitoring tools or consoles, and really they're lacking visibility. So what clients are asking for is a public cloud consumption experience, but everywhere. And so that means services like databases, OpenShift, DevOps tools, and AI, but delivered on-prem, at the edge, or in any cloud infrastructure. And this is a really important, concept, because it's really about consistency. It's having public cloud consumption model, but consistently deployed. And I know that Harish mentioned this in his session, but I'll reiterate. One of the things that we found in IBM Cloud a few years ago, we moved all of our cloud services to Kubernetes. And what that enabled us to do is to operate all of our cloud services in a similar way. And what that allowed us to do is really increase our muscle memory around operations, and also increase the way that we're automating our operations. And so this built in so much additional resiliency that we actually were able to increase our SLA because of it. So this concept of, a public cloud, consumption model, one, that's convenient and it's easy to use, but it's also about consistency, and that consistency can equal resiliency. So I think that's a really important, need in what clients are asking for. A single management and operations experience. And so, this goes into, that pain point of having all of these different clouds, all of these different management tools and consoles, and how do you manage them and juggle them? And then, ownership, operation, updates, and evolution of services, all by the cloud provider. And so what we're hearing is that, clients are wanting to shift the operational burden from having to run services themselves, and shift that to the cloud provider. And finally, flexibility to run apps where it makes sense. And so that may be because of latency. That may be because of, regulation. That may just be a point in time statement where, a application is being refactored, and it may need to run in a specific location on its way to the public cloud. So there's lots of different reasons, or maybe it needs to run at the edge. There's lots of different reasons for, where a workload should run, and having that flexibility is really key. So that leads us to, the definition of IBM Cloud Satellite. And IBM Cloud Satellite is really about launching consistent cloud services anywhere, across any cloud, on-prem, and at the edge, with speed and simplicity. So let's talk a little bit about our the architecture involved with IBM Cloud Satellite. So we're going to start at the bottom row in all of the different deployment options. And so, the first one is the existing infrastructure. So we know that many of our clients have, existing data centers, and they have room in their data center for us to deploy into. And so this is an offering that we provide to give a lot of flexibility. And, we have the details in our docs in terms of the hardware parameters. But essentially, if you have a Linux host, we can, deploy a satellite location into your existing infrastructure. And we find that provides a lot more flexibility for some of our clients, in their journey to cloud. And then, the second deployment option is what we call our IBM Cloud Satellite Infrastructure Service. And this is a service where we actually purchase the infrastructure, we deliver it, we set it up, we install it, we do that all on, for the client. And then we allow the client to consume the infrastructure on a consumption basis. And so, the user, it's a turnkey solution. The user does not have to, worry about setting any of the infrastructure up. We come in and do all that for them. And then we can deploy a satellite host and manage it on that infrastructure. The third option is, of course, our IBM Cloud. And it's always something that we can leverage. And we have data centers globally that we can deploy into. We also have turnkey appliances that our clients can leverage. And then we can deploy to the edge. And finally, we can deploy to other public clouds. So these are all of the different deployment options available for satellite, and we can deploy a satellite location and manage those hosts. And then from there, we can layer on. So whatever, the cloud services that our clients know and love, like Postgres or OpenShift or our DevOps tools, we can deploy into a satellite location, and we run those cloud services as a service for our clients in any of those locations in a consistent way. And then finally, we can then start to deploy software. So maybe you would like to deploy a IBM Cloud Pak, or maybe you'd like to deploy your custom application, and they can all run on satellite in all of these different locations. So let's give another real world example. And this time, we're going to go to the edge. And so this is one of my favorite examples about distributed cloud at the office building edge. And so this client is really worried about worker safety. And so what they've done is created this, we've created a solution with them that uses the cameras and devices in an office building and uses analytics from the video feeds to determine if someone is wearing a hard hat or not. And what we're doing is we can warn somebody before they go into a potentially dangerous area and say, hey, you're not wearing a hard hat. We want to warn you before you get injured or hurt. And so this worker safety, it's a very simple use case. But let's look at what the architecture of this use case would look like. So in this instance, we would deploy a satellite location into potentially maybe existing infrastructure that's at the office building edge. And we would deploy Kubernetes, and in this case, OpenShift is our flavor of Kubernetes, and we run that as a service at the office building edge and the satellite location. And then from there, we could add on software like the Edge and IoT application manager, which would manage all of the devices in the building. And then we could also add the video analytics application that takes all of the video feeds and analyzes it and can tell if you're wearing a hard hat or not. So this is the stack. And you could build this in lots of different ways, but there's a couple of reasons why you might want to use a technology like IBM Cloud Satellite. One is that you don't want to have to send all of that data back to the cloud to be processed. It would be much better if you could, and more efficient, if you could process that data at the satellite location, and that's how you're going to alleviate any potential latency. But there's another reason why you might want to use a technology like satellite, and that's about iteration and agility. And going back to that financial services use case around having to add new features and functions at a very fast pace, that happens all the time. And one of the current situations that we're facing today is with COVID. And I'm actually pitching this deck out of my home office, and my children are being virtual schooled here from home. So we're all having to adjust in new ways. But one of the ways that we need to adjust is our application needs to change from a worker safety use case to a COVID related one, where instead of warning someone about a hard hat, now we're warning someone about a mask. Are they wearing the mask? Are they wearing the mask in a way that is worn properly and not slipped down? And then that use case could potentially change to include things like thermal devices, and then you could take someone's temperature at the edge as well. Or we could look at, the hospital edge and determine, how many people are in a waiting room and when those waiting rooms maybe need to be sanitized. So, there's always going to be new and, interesting challenges in the world that we have to face, and being able to iterate fast based on whatever challenge comes our way is really critical. And so applying cloud native tools and best practices at the office building, hospital, or construction site edge becomes more and more critical. All right, so let's look at another use case. And in this case, we're going to talk about a new market entry. So Andersen Financial Services is looking to expand into a new market. They've got local data residency laws that require data to be stored and processed locally. Can they do this without investing tens of millions in CapEx? So IBM Cloud Satellite allows Andersen to deploy and run the payment application on any host of their customer's choice. And Andersen can manage it centrally as a service, and they can consume it on a consumption basis. So they're not having to spend millions on capital expense. So using a consistent set of security and compliance controls, Andersen Financial is able to do that. And again, it goes into agility. If there is existing infrastructure there, they can deploy application in hours instead of weeks or months. Another use case that we're finding interesting is around having consistency across geographic locations. And so World Shipping has IT operations in dozens of international ports. And although they already use Kubernetes to streamline development and operations, their local teams are spending a lot of time managing software. So through a common set of container images and application configuration, IBM Cloud Satellite enables world shipping to centralize management across all sites. And world shipping reduces time spent on redundant operations, work across ports, and has global visibility of all applications. And this is really a common use case that we're seeing. And this, we're using the shipping example, but we're seeing this in, the retail industry as well, and lots of different industries. It's very hard to find, in some cases, talent. Kubernetes IT or SRE is one of the most highest paying IT jobs in the market today. It's very hard to find those kinds of talent across, in every location. But more importantly, it's very important to manage and operate applications consistently across all geographies. And so this is where we can alleviate some of the pain from our clients, and they can go focus on iterating and inventing for their own business instead of having to manage cloud services. So one of the key outcomes here is resiliency and lack of downtime. And so here's another, another example of increased performance and minimized latency in AI-powered insights. And this example is really about, multiple clouds and multiple locations. A financial services firm is looking to use AI to turn millions of data points from regulatory filings, articles, press releases, and social posts into actionable investment recommendations. And so they need to provide consistent access to best-of-breed data and AI tools across their organization and environments. But many of their applications and data sit on multiple public clouds, while their tools are, consumed as a service from the IBM cloud. With the pace of the market today and the speed and performance, their insights are critical. But they're finding they can get 2 times performance improvement when the AI workloads are co-located with the data. But in order to be successful, they need a uniform set of tools and services across all of these different environments. So they can reduce latency with co-located AI workloads and data, but they're really simplifying overall operations and maintenance with an as-a-service consistent solution. And so this solution would incorporate IBM Cloud Satellite, but also IBM Cloud Pak for data as a service. So we've given a few use cases. Now let's kind of dive into some of the features and functions of IBM Cloud Satellite. So the first and most important is really about rapidly building apps with familiar services. So going into the IBM Cloud catalog and using those services that and love, like OpenShift and databases, DevOps tools, AI, being able to consume those services, but being able to consume them in any of the locations that we talked about. And that's really the key to what Satellite provides. And it's not a management tool. It's actually running the workloads. It's operating the workloads as a service across all of these environments. It's shifting the responsibility from securing and running cloud services. We're leveraging the IBM SRE, the IBM Site Reliability Engineers, for lifecycle of configuration, updates, and patches. Again, we're alleviating latency, the data sovereignty. We're handling sensitive workloads and compliance concerns for apps and their services that are co-located. And then we're deploying containerized apps like Cloud Paks from the IBM Cloud catalog on any of these locations. So let's look at, day 2 operations. And I think this is something that's really key to Satellite. And in one of the features, and it's interesting because it's just a feature, but one of the most requested features that we get is this concept of having a single pane of glass from the IBM Cloud Console. And, we talked about this earlier, but most of our clients are using 5 to 8 different clouds today. And they're juggling different monitoring solutions and consoles, and having one dashboard for operations across all of the environments is so key. It sounds very simple, but it's really, really a cumbersome problem today. Having identity, key, and certificate management all in one place, observability, having central logging and monitoring for apps and platforms, all really key to day 2 operations. The next area is one that we have a lot of experience with internally. Having an auditable inventory of everything you're running, no matter where it lives, and rule-based delivery of resources for workloads. Correct resources are always deployed and up to date on the location. And this is a interesting problem that we've solved internally. So it's one thing to manage a couple of Kubernetes clusters, but when you get into managing tens of thousands of Kubernetes clusters, it gets very unruly very quickly. And one of the things that we've learned and we've built internally at IBM is a project called Razee, Razee, and you can check it out at razee.io. It's an open source project that we founded. But we built this technology out of necessity. When we found ourselves having to manage tens of thousands of clusters, there was automation that we needed to help us be more efficient. And so we built some tools internally, and we've used those for the past 3 years and have had a lot of success with them. And so we decided to open source that, and we built that into Satellite. We call that Satellite Config, and it's a big part of having that auditable inventory of everything you're running, no matter where it lives. And then finally, we have IBM Cloud Satellite Link. It's the two-way tunnel that you control. So Satellite Link works with our clients' existing network configurations and security postures, not the other way around. It has an automated deployment and tunnel management, making setting up a satellite location easy and painless. There's no special network configuration required. It uses common web security ports for reliability and consistency. It has a unified experience with IBM Cloud, providing the client with control and auditing capabilities, plus access for IBM's SRE tools, IBM SRE site reliability engineering tools like patching and updates. It has secure encryption that enables workloads to span locations transparently with support for clients' own key and certificates. And it's got unique and automatic DNS, naming for endpoints that yield predictable operations with easier compliance and audits. And it's auditing and governance for clients' operation using link endpoints for secure communications without special networking or knowledge. All right. So, with IBM Cloud Satellite, all you need is Linux infrastructure, and IBM does the rest. And we really encourage you all to launch your own beta satellite. So if you go to ibm.com/cloud/satellite, you can learn more. You can sign up for our beta. We are going GA with our satellite product on March 1st. All right. So again, I'm Brianna Frank, Director of Product Management here at IBM Cloud. I would love to connect with all of you on Twitter or LinkedIn. Feel free to connect. And I'm going to go check out our chat to see what kind of questions we might have in the chat. And thank you, Dan typed in razee.io, which is our open source project around satellite config. Okay, and so one of the questions I had earlier was around pricing, like how do we price this? And so we'll have the pricing, and we will be deploying that, or we'll be making that public here very soon. But the way satellite works is it's on a consumption basis. So, you might pay a few cents for a satellite location. We charge by the virtual CPU, and then you would just consume the cloud services as you would very similar to what you have on IBM Cloud today. Oh, yes. And you can learn more about Satellite at ibm.com/cloud/satellite. I think we are good. Well, thank you all for listening. I really appreciate it. Please feel free to connect. I'd love to get your feedback or questions. We love hearing from clients and partners or just interested technologists. Thank you so much, everyone.